Welcome to MS 100 lessons, and in this lesson I'll be doing a past paper on Newton's laws. So I'll start by reading the instruction, and then we will analyze this question using the steps that we use to analyze Newton's laws. So the question says the two blocks of mass m and 2.5 kg. Okay, so we have a block of mass m, and with this mass m we can calculate the gravitational force. Okay, and we also have a mass of 2.5 kg. We can also calculate the gravitational force for the 2.5 kg. Okay, so if we were to calculate the gravitational force for mass m, that would be Fg equals to mg, and our mass is capital letter M, and g is 9.8. okay, so that would be 9.8 m. And then if we were to calculate Fg for the 2.5 kg, that would be 2.5 multiplied by 9.8. okay, and that would be 24.5 newtons, right, downwards. All right, so let us continue with the statement. Respectively are connected by a light inextensible string. Okay, so the fact that there is an inextensible string, then it means we will have tension acting on the string. Okay, the string runs over a light frictionless pulley as shown in the diagram below. So this means the tension in the string is the same everywhere. Okay, and the blocks are stationary. So with this statement, the blocks are stationary. It means they are not moving, and the conclusion that we can make from this is that the net force on these objects is equal to 0 newtons in each and every direction. So it means F net in the y is equal to 0, and F net in the x is also equal to 0 because the objects are stationary. So before looking at any intermediate statements that are given in the questions, let us do our analysis using the steps that we have to follow. So if I can remind you with the steps, we have step number 1, whereby you separate the two objects, right? So this means you will be applying Newton's laws on the first object and Newton's laws on the second object separately. So okay, and then step number 2, you draw a free body diagram for the first object and the second object. Okay, and then step number 3, you resolve any forces that needs to be resolved. Okay, so remember, this is our analysis for the question. So you resolve any forces that are not in the x direction and y direction. Okay, so in this case our system of axes that we'll be using is the x direction and that y direction. Okay, so if there's any force which is not in the y direction or in the x direction, we will have to resolve that force. Okay, that is step number 3. And then step number 4, perform our net force in the y direction. Okay, and for this question, the net force in the y direction, right, for both objects will be equal to 0 because the objects are stationary. Okay, and then step number 5, performing F net in the x-axis. All right, and then the last step is solve any unknowns. All right, so let us start with our analysis, right? Step number 1, we separate. We agree that we will apply Newton's laws on the first object and Newton's laws on the second object separately, so right? Okay, And then step number 2, we draw free body diagram for each object. All right, so let us go to step number 2. Let us draw the free body diagram for object 1, and object 1 is that of mass m, and object 2 is that of 2.5 kg. Okay, so let's draw the free body diagram for the first object with mass m. Okay, so if we look at mass m, it is stationary on top of a table, right? So this means between the table and the object there is friction, right? There is static friction because the object is not moving. All right, and since we have a surface and the object is resting on the surface, we must have a reaction force from the table, which is our normal force. Okay, and since we have the mass of the object, we should have the gravitational force going downwards. Okay, and we have the string acting, or the string pulling the mass mkg, so it means we will have tension in that direction to the right. Okay, but let us look at these objects. If these objects were to move, right, in which direction will they move? If there is no applied force on this mass m, right, the only possible direction that this object can move is that the 2.5 kg will go downwards and the mass m will go to the right. Okay, so it means friction is acting in the opposite direction, which is to the left. Okay, so let us look at the free body diagram. The first force that we have gravitational force, because we have a mass of mkg, so we have gravitational force going downwards. Okay, and the second force that we have the normal force, which is exerted by the table on the object. Okay, so we have the normal force going upwards, and we have tension going to the right. Okay, and then we have static friction, which is going to the left. All right, so that is our static friction. So these are all the forces which are acting on the mass m kg block. So let us draw the free body diagram for the second object, which is the 2.5 kg. So looking at the 2.5 kg, we have our mass of 2.5 kg, therefore we have gravitational force acting downwards, right? And we also have that rope acting, or it is pulling the 2.5 kg upwards, which means we have tension acting upwards. Okay, and there is no surface on this object, right? So there is no normal force acting on this object. There are only two forces which are acting, which is the gravitational force going downwards and the tension going upwards. Okay, so the free body diagram for the 2.5 kg, right, we have the gravitational force for the 2.5 kg, and we have the tension acting on that 2.5 kg block. Okay, so this is step number 2. We draw the free body diagrams for each and every object, right? And then now let us go to step number 3. Step number 3, we resolve any forces which are not in the x direction and the y direction. So looking at the free body diagram for mass m, we have normal force in the y direction, right? So that is fine. Fg in the y direction, that is fine. Tension in the x direction, friction in the x direction. So we don't have any force that is not in the x direction or the y direction. Okay, so there's no need to resolve any force in the mass m free body diagram. And then if we look at the free body diagram for the 2.5 kg, we have tension, which is in the y direction, and we have Fg, which is in the y direction. So there's no need to resolve tension, there's no need to resolve Fg, because they are both in the y direction. Okay, so there's no need to resolve even in the free body diagram for the 2.5 kg. Okay, so just to remind you, the system of axis that we are using, right? We are using a system of axis whereby we have the positive y-axis going upward, the negative y-axis going downwards, positive x direction going to the right, and negative x direction going to the left. Okay, all right, so we are done with step number 3, which is resolving. There is no need to resolve any force in the free body diagrams, right? So now we can go to step number 4, which is net force in the y direction for both objects. So let's start with the block of mass m, F net in the y direction. Okay, so that is step number 4. So we have net force. So remember, this is in the y direction. Net force equals to ma. And then looking at the net force in the y direction, how many forces do we have acting in the y direction? For mass m, we have 2 forces, which is the normal force going upwards, right, which is positive, and Fg going downwards, which is negative. Remember the system of axis that we are using? We are using x direction as positive to the right and negative to the left, right? Negative y downwards and positive y upwards. Okay, so hence I'm saying normal force is positive and Fg is negative, right? So the net force in the y direction for this object would be, we have the net force which is positive, we have Fg which is negative, equals to the mass of the object and the acceleration. But if you look at the acceleration, right, in the y direction, this object is stationary. It is not accelerating in the y direction. So the acceleration in the y direction is equal to 0. So we have normal force minus Fg is equal to 0, right? So if we can calculate the normal force, that will be equals to Fg. Okay, and remember, one of the reasons why we perform our net force in the y direction is to obtain the normal force, right? So the reason is to obtain the normal force, and after obtaining the normal force, we usually obtain our friction for that object, right? So now we have calculated our normal force in this case, and we can see that our normal force is equal to Fg, right? And we have already calculated Fg up there, and Fg is equal to mg, and the mass of the object is m, which is capital letter M, multiplied by g, which is 9.8. So Fg is 9.8. Okay, so it means the normal force is equal to 9.8 m, which is equal to Fg that we have calculated up there, right? So this is how we found Fg. Okay, so we have obtained our normal force, right? So can we obtain our friction now? But looking at the statement so far, we haven't looked at the intermediate statements that are given in the question, right? Looking at the main statement up there, we do not have the coefficient of kinetic friction, right? So we will leave it like that, and we'd say our friction for that object is equal to the coefficient multiplied by the normal force, and we have Fk equals to coefficient multiplied by the normal force is 9.8 m. Okay, so let us leave it like that. So now we are done with the Fnet in the y direction for the mass m kg block. So now let us go to Fnet in the y direction for object number 2, which is the 2.5 kg, right? How many forces do we have acting in the y direction? We have 2 forces, right? We have tension, which is positive, and we have Fg, which is negative, right? So that would be tension, which is positive, and Fg, which is negative. That is equals to the mass of the object multiplied by the acceleration. But remember, these objects are stationary, okay? So it means there is no acceleration. Acceleration is equal to 0 both in the y direction and in the x direction, okay? So the acceleration for this object in the y direction is equal to 0. So that would be tension minus Fg of this object equal to 0, and the tension is equal to Fg, okay? But we have already calculated Fg up there, right? And we have obtained Fg to be 24.5. So we can calculate it again here to say Fg is equal to mg. The mass is 2.5 and g is 9.8, right? And when you say 2.5 multiplied by 9.8, you get 24.5 newtons downwards, okay? So now you have your tension. Your tension is equal to Fg, right? Which is 24.5 newtons. So now there is your tension. You obtain this by performing the Fnet in the y direction for this object. Alright, so we are done with Fnet in the y direction for both objects. Now we have to go to the next step, and the next step is to perform the Fnet in the x direction. So Fnet in the x direction, we'll start with the mass m kg. So that is step number 5, okay? So we perform our Fnet equals to ma in the x direction. So how many forces do we have acting in the x direction? For mass m, we have 2 forces, right? We have the tension to the right and we have friction to the left, right? And following our system of axes, anything that is a vector, we have to include direction, right? And looking at a force is a vector, so it has magnitude and direction. So we have to apply this system of axes if you substitute a force, right? That is why we said normal force is positive because it is going upward, right? And we said Fg is negative because it is pointing downwards, okay? So now another thing that is a vector, acceleration. Acceleration, you also have to include the direction in this case, right? But what about the mass? Mass of an object is a scalar quantity, so you don't have to include the system of axes when you substitute the mass, right? So when you substitute a force, make sure you include your direction. When you substitute acceleration, make sure you include your direction. All right, so let's continue to perform our Fnet equals to ma in the x direction. For this object, we have 2 forces, tension and static friction, okay? And tension is positive because it is pointing to the positive x direction, and static friction is negative because it is pointing to the negative x direction. So we have tension minus Fs equals to the mass of the object, right, multiplied by the acceleration. But look at the acceleration now, because we said the objects are stationary. It means Fnet equals to 0 because the acceleration is equals to 0. We said both in the y direction and in the x direction, they are all equals to 0. So acceleration is equal to 0. So your net force is actually equals to 0. So you have tension minus Fs equals to 0, right? And you have your tension equals to your friction. But remember, we have already obtained tension in the Fnet. In Fnet equals to, in Fnet in the y direction, we have obtained tension to be 24.5, right? And remember, the tension acting on this rope is the same everywhere, right? So we can substitute our tension to be 24.5, and now we can obtain our static friction, okay? So our static friction is equal to 24.5 newtons. So there we go. We have calculated our static friction by performing the Fnet in the x direction for the mass m object. All right, so let us continue to perform the Fnet in the x direction for this object. okay? F net equals to ma for the 2.5. But if you look at the free body diagram, there is no force acting in the x direction, so we can't perform the F net in the x direction for this object, right? So there's no need because there is no force acting in that x direction. So this we will not do, okay? And then the next step is to solve if you have any unknowns. All right, so this is all what we do in our analysis, right? Before we look at the questions, okay? So let us go to the questions now. 2.1.1, state Newton's third law in words, okay? So Newton's third law in words, it states that when object A exerts a force on object B, right, object B will exert an equal amount of force in the opposite direction. So when object A exerts a force on object B, okay, object B will exert an equal amount of force in the opposite direction. And remember, when object A exerts a force on object B, this object B will exert an equal amount, and that happens simultaneously. So object B will simultaneously exert a force on object A, which is equal in magnitude and opposite in direction, okay? So it will exert an equal amount of force in the opposite direction, okay? So that is the first question, which is just stating. So let us go to the calculations now. 2.1.2, okay? So that was 2.1.1. 2.1.2, the question says calculate the tension in the string, okay? And remember, we performed our analysis, and from our analysis we have calculated the magnitude of the tension, okay? So where is the tension? So that is the tension. We have obtained tension from F net equals to ma in the y direction of the second object. So you take that working and then you just copy it down there, right? So you just transfer this working and then put it here. So I'll just write here that this is from the analysis. Okay. All right. So let us look at the next question. So remember, we have obtained our tension to be 24.5 newtons, right? Okay. So let us look at the next question. The coefficient. Now they said the coefficient of static friction, right, between the unknown mass mass m and the surface is 0.2, okay? So now they're giving us some extra information in the intermediate statement, okay? So now they say calculate the minimum value of mass m that will prevent the blocks from moving, okay? And I will explain later why they are saying the minimum, right? All right, so now they gave us the coefficient of static friction, right? Remember, when we perform our analysis, we have separated, we have drawn our free body diagrams, we have resolved, and now let's go to the F net in the y direction, okay? So looking at the F net in the y direction for the first object, mass m, right? We said the acceleration is equal to 0 because it is not accelerating in the y direction, right? And we have found that the normal force is equal to the gravitational force, and our gravitational force is 9.8 m, right? And now, okay, so here it has to be static friction. Okay, it has to be static because the objects are not moving. So now in this question they gave us this value, which is coefficient of static friction, and they are saying it's 0.2, right? And remember, from FNet in the x-axis we have found what static friction is, right? Static friction is 24.5. We have this value 24.5, and now they are giving us this value, right, which is the coefficient. So now we can just substitute whatever we are given from the question and whatever we have calculated in this equation, and then we solve for mass m, right? So static friction is 24.5, right? This is equals to 0.2, which is our static friction, the coefficient of static friction, then multiplied by 9.8 m. So that is the mass that we are calculating, right? So that would be 24.5 equals to 0.2 multiplied by 9.8, right? So that would be 1.96 m. Divide both sides by 1.96, divide by 1.96, and the mass is equal to 24.5 divided by 1.96, right? And the mass we get 12.5 kg. Okay, so why do they say minimum, right? They say calculate the minimum value of mass m, right, that will prevent the blocks from moving. So this is the minimum. We have found that the minimum is 12.5 kg, right? So if you put any mass which is greater than 12.5, these objects will not move, right? So if, for example, you put 20 kg for that block, the object will not move. So this 20 kg will prevent the blocks from moving. Even if you put 30 kg, 13 kg, any value which is greater than 12.5 kg will prevent the blocks from moving because it is heavier, right? But if you put any mass which is less than 12.5, this object will start moving. Okay, so that is why they said calculate the minimum, and the minimum we have found to be 12.5. So in this working, you take your working from the analysis, right? You take this working which enables you to calculate your static friction, right? And this work that enables you to calculate your normal force, right? And now they have given you your coefficient, so you include this in your answer. Okay, that is what you include, and also include that. Okay, so the answers for 2.1.3 is also from analysis. Okay, all right, so according to our analysis or the steps, we have calculated each and every value or each and every unknown, right? So we are basically done with our analysis. So let us look at the next question. So the next question says the block of unknown mass is now replaced, right? So the moment they replace something, you perform your analysis again, right? The block of mass of unknown mass m is now replaced with a block of mass 5 kg. Okay, so now instead of mass m, we have 5 kg, right? And looking at this question, 5 kg is less than 12.5, right? So if we insert any mass which is less than 12.5, these objects will now move. They will now accelerate, right? So now we expect these blocks to accelerate, or we expect these blocks to move, right? Because now the mass m is less than 12.5. Okay, so now they say that 2.5 kg block now accelerates. Okay, now we see that they accelerate because the mass of the block on the surface or on the table is less than 12.5, which is 5 kg. Okay, and then now the coefficient of kinetic friction between the 5 kg block and the surface is 0.15. Okay, so the question says calculate the magnitude of the acceleration. Okay, so now this is a new question. It needs new analysis, right? Following the same steps that we have followed up here. Step number 1, you separate. Okay, step number 2, your free body diagrams. Okay, so let us start from step number 2, whereby we draw our free body diagrams for this new question. Okay, free body diagram for now is the 5 kg. Okay, now we have the mass of the objects 5 kg and the 2.5 and the 2.5 kg. Okay, so we still have the same free body diagrams. We have the Fg, which is weight. We still have normal force. Okay, we still have tension acting in that direction, but now the objects accelerating, they are moving. It means the friction now would be Fk instead of Fs. Okay, and as I've explained before, that the only possible way that these objects can move or accelerate is that the 2.5 kg will accelerate downwards and the mass m kg or the 5 kg now will move to the right. Okay, so that is why friction is pointing to the left and tension is still pointing to the right. Okay, so the free body diagram for the 2.5 kg is still the same, Fg and tension upwards. Okay, so now what you have to note is that the objects are now accelerating. Okay, so when the object's accelerating, there is a change in that force. It's no longer static friction, but it is now kinetic friction. Okay, so that is note number 1. And note number 2 is that the tension acting on the rope, it changes. Okay, so because the tension inside the rope depends on the amount of pulling that you apply on that tension. So the amount of pulling that you'll apply or that is applied when the objects are stationary will not be the same as the amount of pulling when the objects are moving. So the tension is now different. So we are not going to use that 24.5 that we have calculated in the previous analysis, right? So the tension is different. So now our tension is an unknown. Okay, so let us continue to the next step. Next step is we resolve, right? So when we resolve, we check any forces which are not in the x direction and y direction. And looking at the free body diagrams, okay, all the forces, they are either in the y direction or in the x direction, so there is no need to resolve. Okay, so step number 4, we perform our Fnet in the y direction. Okay, so let's perform our Fnet in the y direction for the 5 kg. So Fnet in the y direction, that is Fnet equals to ma. How many forces do we have in the y direction? We have 2. Okay, we have the normal force, which is positive, and we have Fg, which is negative, right? Equals to the mass of the object, but the acceleration is still 0 for the 5 kg. Why? Because the object or that object is moving in that direction, which is to the right and not upwards. Okay, or not upwards or downwards. So acceleration in the y direction is 0. So that would be normal force minus Fg equals to 0. The normal force is equals to Fg. Okay, but remember Fg is equal to mg, and the mass of the object, you are given 5 kg and g is 9.8. Okay, so the magnitude of the normal force is 49 newtons. Okay, so that is the main outcome for performing the Fnet in the y-axis, which is to obtain your normal force. And after obtaining your normal force, remember you have to calculate your friction straight away. And now your friction would be equals to, so let us look at the statement, are we given the coefficient between the surface and the block? We are given the coefficient of kinetic friction to be 0.15 from the question. So we use 0.15 multiplied by the normal force, which is 49. Okay, so the friction is equal to 0.15 multiplied by 49, and we get 7.35 newtons for our kinetic friction. Okay, so we are done with Fnet in the y-axis for the first object. Let's go to the second object. Fnet equals to ma. How many forces do we have acting in the y direction? We have two forces. Tension, which is positive, Fg, which is negative, right? Equals to the mass of the object. So now let us look at the acceleration. I said anything that is a vector, you substitute with direction, okay? And with our system of axes, we are using upward as positive, downwards as negative, right? To the right as positive, and to the left as negative, right? So tension is positive because it is pointing upwards. Fg is negative because it is pointing downwards. The mass of an object is a scalar quantity. It does not need direction. But what about acceleration? So with acceleration, you substitute with direction, okay? Because it is a vector quantity. And this object is accelerating downwards, right? And downwards, in this case, it is negative. So that would be negative a, because we have to stick to our directions, and acceleration is a vector quantity. So now that would be tension minus Fg. So Fg for this object, for the 2.5 kg, we have already calculated it up there, which is 24.5, right? So Fg is 24.5, which is 2.5 multiplied by 9.8. So the mass of the object is 2.5. So that would be 2.5 multiplied by negative a. Okay, so T minus 24.5 is equals to negative 2.5 a. So that is equation 1, because we have two unknowns on this equation. So we would say equation number 1. So we are done with Fnet in the y direction for both objects. So let us continue to step number 5, which is Fnet in the x direction. Okay, Fnet in the x direction. Let's start with this object, the 5 kg. In the x direction, we have two forces acting, right? So that would be tension, which is positive, right? Because it is pointing to the right, and Fk, which is negative, because it is pointing to the left. And that is equal to m. Look at the acceleration now. The acceleration, this object is accelerating to the right, which is to the positive, right? So it means acceleration would leave it as positive. So now we have tension minus kinetic friction. We have calculated kinetic friction to be 7.35. Okay, 7.35 equals to the mass of the object is 5 kg times acceleration, right? So T minus 7.35 equals to 5a. That is equation number 2. Okay, so that is the Fnet in the x direction. So let us perform the Fnet in the x direction for the second object, but as you can see, we do not have any forces acting in the x direction. So Fnet in the x direction, for this one, we will not perform it. Okay, so now we have equation 1 and equation 2, right? And equation 1 has two variables, which is tension and acceleration. Same applies to equation number 2. It has two variables, tension and acceleration. So now we want to solve for the tension and the acceleration. Okay, so we will use simultaneous equations method, whereby we can make T the subject of the formula here, and that would be 5a plus 7.35. That is equation number 3, right? And then you substitute equation number 3 in equation number 1. Why do we substitute equation number 3 in equation number 1 because we have formulated equation number 3 using equation number 2, right? So now we have to substitute this equation to equation number 1. All right, so wherever we see tension, we will substitute 5A plus 7.35 in equation 1. So we have tension, and that is the first letter there. That would be 5A plus 7.35, okay, minus 24.5 minus 24.5 equals to negative 2.5A. Negative 2.5A. So let us solve for acceleration. So if I take this negative 2.5A to the left hand side, that would be 5A plus 2.5A, okay, and then 7.35 minus 24.5, that would be negative 17.15, right, equals to 0, and that would be 7.5 A equals to positive 17.15. Divide both sides by 7.5. Divide by 7.5, and your acceleration, the magnitude of the acceleration is equal to 2.29 meters per second squared, right? So now let us calculate the tension. So I can calculate the tension using equation number 3 because I have already made tension the subject of the formula. So tension is equal to 5 multiplied by 2.29, which is my acceleration, okay, plus 7.35. So the tension that I obtain would be 5 multiplied by 2.29, okay, plus 7.35. And the answer that I'm getting is 18.8. So I now have my tension. As you can see that the tension now has changed. It is no longer 24.5, but it is now 18.8. Okay. So we are done with our analysis for this question. Let us look at what they were requiring from the question. So they say calculate the magnitude of the acceleration for the 5 kg block, right? And we have calculated our acceleration from our analysis to be 2.29. And furthermore, if they were asking for the tension would be 18.8 newtons, right? So remember the acceleration on the 2.5 kg would be downwards, right? And the acceleration on the 5 kg would be to the right. Okay, so 2.1.4, the answer is also from analysis.